I want to address this whole nonsense of high levels of H2, because more H2 is not necessarily more effective. While most of the research on hydrogen gas as a therapeutic tool in the treatment and prevention of illnesses focuses on a concentration of about 2.5 parts per million. And so that's why the companies like the one I just showed you the picture of, they're touting over 3 parts per million, three parts per million and more. They don't take into consideration that the water that they're bubbling that hydrogen in is not going to change the cell membranes. It's not going to fully hydrate the body. And they don't take into consideration that in ionized water, we have the extra added value of the free electrons and a more effective delivery system of the water into the small intestine. So one of the things that happens when you drink water is that if you're drinking plain water, and if it's pretty much room temperature, and it's slightly alkaline, it passes through your stomach very quickly and directly into your small intestine, where it's absorbed into your bloodstream, it's absorbed into your lymphatic system, and it starts an immediate cycle of hydration. When you're bubbling water into reverse osmosis water, you have a very acidic water which does not pass through your stomach quickly and does not get into the small intestine quickly. So the vast majority of the hydrogen gas is going to be dissipated in the stomach acid because it's going to sit in the stomach longer. Does that make sense? Your stomach is an acidic environment. And if there are additives to water, it always starts a digestive process. So reverse osmosis and distilled water are very acidic, and so they are always going to sit in the stomach longer than a slightly alkaline water. So when you're drinking ionized water, you're drinking something that has a slightly alkaline pH, causes it to pass through the stomach faster, carrying with it some hydrogen gas and some free electrons. So now we've got magic getting into the small intestine so it can get into the bloodstream and into the lymphatic system and be delivered out to the cells in the body. The other thing to keep in mind is that unlike free electrons that just, they're like magnet, here we go, here you go, free radical, here's an electron, it's all yours. When hydrogen gas reacts to in some instances, it's going to react just like other antioxidants, the ones that have the drawback, because if it's just donating, if the hydrogen gas is just donating its electrons, guess what's left behind? Positively charged hydrogen ions, which are free radicals. So, like I said, more hydrogen gas in your water is not necessarily more effective. It can have 2 drawbacks. Depending on the water it's being bubbled into, it can sit and have virtually no therapeutic effect because it just gets used up. Or it can actually stop some free radicals, but also leave some weak free radicals in its wake. This is why, in my opinion, ionized water is so far superior to water that's just had hydrogen gas bubbled in it, no matter what the amount. Robin, Taylor, do you have a question?
Yeah, do you remember Dr. Steve from last Q&A?
Yes.
The chiropractor? Yeah, he was in today and he wanted to piggyback on this. There are those hydrogen-infused products that are on the shelf.
Yeah.
Are they shelf stable? Like, can it be where they can keep the hydrogen in for a long
Hydrogen gas is completely volatile,
Right.
right? You know, hydrogen bombs, the Hindenburg, hydrogen gas is highly volatile. It will not stay inside a plastic bottle. And those sticks, those hydrogen sticks, those are just a bunch of nasty chemical of minerals that are super low quality minerals that create a chemical reaction to create some hydrogen, which dissipates quickly. It dissipates quickly. Hydrogen is volatile. It is not shelf stable.